All right. Let's turn down the front lights a little bit more. All right, perfect. Thank you. This man needs no introduction.
And apparently we'll get done.
That's okay. No, but seriously, he's a solar system ambassador and he's great.
Hey, I'm Bob Trembley.
His name was on the slide.
I've been an amateur astronomer since about yay, and I joined the boss in 2011. Been doing a lot of outreach, and I recently started working full-time for the Vatican Observatory Foundation. My wife says because of that, I'm much easier to live with now. So I do a lot of astronomy outreach. I love observing the sun. I just gave my sun presentation to my wife's class again last week, so that's pretty cool. So I work for the Vatican Observatory Foundation. David Levy, I'm waiting for something from him. I do posts for him now, which is pretty cool. So yeah, Brother Guy, this guy's my boss, and this is a Sagan medal that he won for excellence in public communication and planetary science. And the other side is his name, spelled Council Mango.
Oh no!
Connie says, don't you want him to change it? He's like, ooh, I want it to stay just like this. But in 2016, 2017, my wife and I ran the Endeavor Space Academy, and we used a lot of the apps that I'm going to be showing here tonight. And by the way, my wife told me that we are going to be able to do this again next year, so I'm thrilled. So I want to redo the curriculum and everything, teach astronomy and space science. Yay! So I've been a computer gamer since Green Bar, you know, since Star Trek and Modem Coupler, and I've been doing computer games forever. And computers have gone up in technology. This is the graphics card that's in my laptop here, and they've gotten ridiculously fast and ridiculously cheap, and they can finally run simulators. And one of the simulators I'm not going to be showing, I just found out about this recently, is this thing. It's Overview VR. It requires a VR headset, which is a couple $100. But this is like a tour of the universe in virtual reality. You stick the headset on. Yeah, I think something like this would be really cool at an astronomy at the beach. But again, about $400 some odd for a single VR headset. But I've heard it's awesome.
Except donations.
The other spaceship I will be showing is Space Engine, and it's really cool. This app. I've never seen an app that gives you more of a feeling like we are living in a sea of stars than Space Engine, but some of these other apps do something similar. But, so, less PowerPoint, more demos.
Question?
Yes.
What machine platform do these things run on?
Everything that I'm going to be showing here tonight will run on the PC and the Mac. And this is the first one. This is NASA Eyes on the Solar System. Think NASA Eyes. It's free for PC and Mac, and it wants an internet connection. So I'm thrilled that the internet here is working tonight. It comes up with this as the default screen. And I'm just going to start with Eyes on the Earth. What this allows you to do is visualize climate data, and it shows you all of the satellites that are. Yeah, go full screen. All the satellites that are currently collecting climate data, and yeah, this is what this app is really cool for. But you can visualize all sorts of things like carbon dioxide, and if you want to see it change over time, it'll do that. It's got a whole ton of different data sets. You want water vapor, you want sea level, you want gravity, soil moisture. Just tons and tons and tons of this data gets updated constantly. And one of the coolest things it's got, what's the name? This is NASA Eyes on the Solar System. It's got several different modules. This is Eyes on the Earth. The data animations is really cool. Let me slow it down. So, let's see. Atmospheric rivers. This is one that pretty much impressed me the most. Gives you, shows you the atmosphere and then It shows you where there are rivers in our atmosphere. There's just tons of simulations like this.
Wow.
Where is the dioxide?
This is carbon dioxide, right?
Yep. So yeah, there's tons and tons of visualizations. So I'm going to close this and reopen it because it doesn't want to go back to the main menu for some reason very well. It just takes a while. Now, I've been in contact with the developers of this application. They are going to be releasing a new version of this, and it looks like they're going to be releasing some modules as web apps, which is going to be pretty cool. So, eyes on the exoplanets. I'm going to hit this one next. This shows you Kepler data of exoplanets that's been discovered and models them using a graphics engine. The graphics engine they used in this is the same graphics engine used in a lot of gaming systems. So yes, we'll go full screen. So I'll let it talk.
You are now 1,000 light years from Earth. Looking at all the stars where planets have been discovered. Our sun is at the center. Our galaxy is home to more than 1 billion stars. The stars you see represent only a tiny fraction of those. Click and drag with your mouse to explore our galactic neighborhood and search for planets that might be hospitable to life.
And that's all of the nice announcer. But what this is showing, these are all the exoplanets that we've discovered, and you'll note a lot of them are in this wash down there. That's the original Kepler search, and I believe what's going on with these star ones.
Hey Bob, we can't hear you over the music.
Oh, sorry. Shut that up. There we go. Yeah, this is Kepler data, and this is where the Kepler search and the K2 searches are where you get these stars branching out. But it's got, you want to see different exoplanets, here's some extreme exoplanets, some of the weirdest ones. You can go to these, you got hot Jupiters, and there's an egg-shaped one that's really cool. What this does is this shows you the exoplanet system and a hypothetical artist rendition of what that would look like. So that is a hot Jupiter, and it's got all different information here. You can compare it with our solar system, and you'll notice a lot of these things fit well inside the orbit of Mercury. That's the case for a lot of these things. I think number 2 here is a weird one. Yeah, there we go. This planet is shaped very oddly. It is very close to its primary. It's very, very hot, almost incandescently hot up front, and it's really coolish in the back. So it's got all these different ones, and you've got rocky planets and brown dwarf candidates, and the smallest ones. It's got the TRAPPIST system in here, but it's got thousands of these things. So yeah, you can go around here and you can compare the size with Jupiter. A lot of these things are pretty darn large. So that's eyes on exoplanets. What I use the most is the middle section of this called eyes on the solar system itself. And it starts off. Wait for it. It says this really wants an internet connection. I'm thrilled it's working here. So if you don't have it, it's just.
Hey Bob, this is from JPL?
Yeah. Direct from them. So it starts off with a top-down view of the solar system as it is right now. Like a lot of gaming systems, you can pan and zoom and stuff like that. Let's click on the Earth here. Just go to the Earth. Something. And it's so fast. I'm loving it. So it shows you all of these things, and it's really cool to speed these guys up. So these are several of the active satellites orbiting the Earth right now. And so you can go to any planet. Look here, I can show you where you can go. Here's the different destinations. In the solar system, you've got all the planets and moons, the dwarf planets, tons of asteroids, some comets. I think Turbo George Minko is actually shaped right. Yep, there it is. And it's jetting, isn't that nice? It's the first time I've seen that.
P67.
So you can go back to the beginning by just clicking on the logo here. And I want to show you the InSight probe just launched recently. And it's got these two CubeSats, and one's ahead and behind it, and these are these CubeSats. You know, I don't know if you saw the presentation in Macomb a while back. A 1U CubeSat's about like that. A 3U CubeSat's about like that, and a 6U. This is a 6U. It's about yay big. And so that's what it is. And let's zoom out here. There's two of these things, and what these things are going to be doing is transmitting telemetry from the InSight lander as it descends down to Mars. So there's InSight and Marco A and B. One's ahead, one's behind, and there's InSight. Those things are going to fly by Mars. And let's go back to the center here. And they're just going to become more space junk. But it's a technology demonstration, essentially. And I bet if it works right, you're going to be seeing a lot more of these.
Okay, wait, what is the purpose of these little companions?
Technology demonstration. What they're going to do is transmit telemetry from the InSight as it descends down to Mars' surface.
Oh, all right.
So real time, instead of having to wait for like a Mars reconnaissance orbiter to go overhead or something like that. Excuse me. OSIRIS-REx. This is an asteroid sample return mission. It's on its way to asteroid Bennu right now. Get the lighting a little better here. You can flip lighting to real flood lighting, which is the sunlight's coming from everywhere. Let's show you what this is going to do and make sure that we're looking at asteroids. We do not have asteroids. There it is. I just turned asteroids on. I'm going to zoom out. I'm going to show you the path that OSIRIS-REx is going to take, because this is crazy. Zooming out, zooming out. Space is big. There we go. All right. So there's Bennu. That's its destination. It's going to asteroid Bennu. Now I am going to increase time a lot here.
When's the arrival?
Pardon me?
When is the arrival?
What's the arrival date?
I'm not exactly sure. I'm going to find out in just a second, though. Blink. Zoom, 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 zoom. Space is big. So right there was arrival, which puts it at about October of 31st. Now it's encountered Bennu. I'm just gonna click in on Bennu here. Center that. All right, so there's OSIRIS-REx. Look at that. Goes into orbit. Then does this crazy, whips around at this crazy method. I'm sure there's a reason for it, but I've never seen anything like this before. Look at that.
It's an Etch-a-Sketch.
And eventually it goes into close orbits, mapping orbits that are really, really close for the better part of a year.
Come on.
How can it have such sharp kinks?
Yeah.
Well, I'm doing 1 day per second here.
Still.
It seems to use a lot of
There you
fuel.
go.
They
So
have to
then
turn
it
around.
goes into orbit like that, and I love how it's changing in inclination just a little bit there.
So Bob, do you count those trajectory corrections? Is that what you think?
Yep, this is what's going to do.
Wow. You wonder why.
Yeah, so the mapping period of when it's in orbit of Bennu is going to be for the better part of a year. And then it's looking for the spot to touch down. It's going to come in and it's going to come down this thing hanging off it. Is just going to hang off the surface. It's going to puff nitrogen, kick some stuff up, and bring that back in like 2023 or something like that. So one of my favorite missions is Cassini. Well, unfortunately, it is no longer in orbit of Saturn, but the Saturn system is really beautiful in here. Really cool to see. It's really, really nice.
I thought the top was hexagon.
Oh, look
It's
at
there.
that.
Okay.
Never seen that.
Isn't that weird? If you want to see the moons orbiting it, you can do that. We have all the moons. Let's turn on the minor moons. So all these moons are like the major moons. They're pretty much, except for Apodus, are orbiting in this plane here. You turn on the minor moons. There they are. You get just a mess of stuff orbiting Saturn.
Can you brighten the lines and try?
You know what, I can't. This actually shows up better in Universe Sandbox. I'll show you that in there. Speaking of which, let's go to Universe Sandbox. So yeah, I do a weekly in the sky post, and I pull pictures out of NASA Eyes on the Solar System all the time. So this is Universe Sandbox. This is a physics simulator, and it's aware of climate and material properties. It doesn't simulate things entirely accurately, as Jeff can attest to, but I like this one. Is Scott Schneider here?
No.
No, he gave a presentation a while back, and talking about what if. So this is the solar system, and one of the questions asked was, what would happen if the sun just disappeared? Well, press the delete key.
Stuff would fly off.
There you go.
Holy.
So you'll notice Mercury whipping off there because it's going the fastest closest to the sun. So yeah, this thing has just a ton of different simulations, and they've added, they've added some new things like here's the that interstellar asteroid on the hyperbolic trajectory. They're pushing this one hard because they just implemented the hyperbolic trajectories in this thing. And I believe, I think they also have that one the Jupiter. There it is. The retrograde asteroid. That's the one by Jupiter. So let's speed that up a bit.
There's cool.
So it's weird having something orbit like that. But one of the cool things that Universe Sandbox does is model collisions. And let me just run that one. With sound. I know, there's no sound in space, but yeah.
Wow.
So what would happen if you threw the Earth or the Moon at the Earth? One of the really cool things that this lets you do is, again, play with gravity and stuff. So I'm just going to do a new simulation. I'm just going to add the Earth right here, going, and slow it down a bit because it's always too fast. And now let's put the Moon in orbit, really, really close to the Earth. Anybody know what's going to happen?
It's gonna go into Roget's limit and split up.
Well, let's put it really, really close.
It'll break up.
Right here.
Floating.
And that's exactly what it's doing. As it orbits, it's within the Roche limit.
Roche limit.
And there we go. More stuff breaking up and out of it. Eventually you'll have a ring system here. But what's happening is the gravitational forces between the bodies is enough that it's pulling the Moon apart, and this stuff is just like drifting off of it. And it's following standard orbital mechanics. The stuff that's closer into the planet orbits faster, so it kind of goes down like this. The stuff further out drifts further away, and eventually you will have a ring system over the course of a lot of time. So it's got, you can model supernovas. It's got just tons of simulation here. Explosions, like, what would happen if the sun went supernova? Well, the sun can't, but what would happen if it did? Well, things would be very unfortunate. Yeah, they're very proud of this. They just really released new code to do this. Every supernova looks completely different now. So you can make pretty pictures. So what else do we have here? Here's an example of things orbiting faster than they get closer. Whoa! Okay, wasn't expecting. Which one's that open? Floating Earth. Okay, that's not what I wanted. I wanted the 8 things around. All right, here's Saturn and the moon. Let's open up that one. So there is all the different moons of Saturn.
Amazing.
So yeah, the major moons are all in this nice equatorial plane, but as you get further out, it's just a mess. And what's interesting is Jupiter, Saturn, Uranus, Neptune are exactly the same when it comes to this. And it's almost like they have a mini Oort cloud of their own. I'm wondering, is there some distance where that starts happening? Because it seems like it's a thing with gas giants. So it's got a whole bunch of simulations. You can, let's see, exoplanets. It too has exoplanets modeled. This is the TRAPPIST system. And it shows you the habitable zone and the frost line. And you can show that for every system. You can do climate simulations. Let's go find those. There it is, climate simulation. So yeah, it's actually, it's modeling the climate here. So you can throw more water at it, you can terraform Mars by throwing comets at it, or just throwing water at it. But you can see it. See the Earth breathing here, which is kind of cool.
Nice to see. Can you do continental drift?
Pardon me?
Can you do continental drift?
I don't think so. Actually, let me do something new. I was playing with this the other day, and I wasn't actually not expecting this. Let's add the Earth here. Boink. And let's add another Earth in a really close orbit like that. Anybody know what's going to happen?
So what are we adding to what?
The Earth, orbiting the Earth.
Oh, come on.
Just, okay, a massive body the size of the Earth orbiting another massive body the size of the Earth.
Cast the other one off. Yeah.
There, that's what happens.
Yeah.
So it's real easy to make incandescent planets in the simulation.
Could you make it stable depending on parameters?
So but you can click on any one of these bodies and just fool around with, pretty much every property that you can possibly fool with: motion, composition.
Bob,
Yes.
do any of these simulations do cosmological dynamics?
Like galaxies?
Like the expansion of the universe?
No, none. Okay. Not this, no.
What about 3-body orbiting situations?
Well, Kerbal Space Program doesn't. I'm not actually sure about this. I mean, you can have tons of bodies in here, and it will eventually
Yeah,
say,
like,
I can't go any
3
faster. The
Earths.
simulation's taking too much processing power. But yeah, it's got physics stress tests in here where you can bring your PC to its knees if you want to. Snorkel, Swift Tunnel, let's do. There it is. Shoemaker Levy. Let's run the simulation, and it actually looks pretty darn close to what actually happened. All what, 27 of the darn things?
27 what?
Pardon me?
Oh.
27 what?
Impact.
Oh. Oh, Shoemaker Lee, oh,
Yeah, 1994.
yeah, they did it in alphabetical order too.
Any Game of Thrones fans here?
Objection.
This is the Game of Thrones system modeled in here, the land of ice and fire. Not exactly sure how accurate this is, but I sure wouldn't want to be in a planet orbiting a binary system. Not so much. So again, there's tons of different simulations. I mean, what would happen if a 1 million mass black hole went through the solar system? You don't want to know. That's bad, but so that's Universe Sandbox, and I'm going to get to my favorite, which is Kerbal Space Program. One thing I don't like about this is it's hard to find the exit. There we go. Exit.
They don't want you to exit.
Well, they don't. They really, really don't. Excuse me. This is Kerbal Space Program. This was an indie-based game made by a small developer out of Mexico. It recently got purchased by Take-Two, which is the makers of Grand Theft Auto, which upset a lot of the players because they tend to do things to the game like prevent mods from working and stuff, but that hasn't happened yet. There's been no repercussions that I've seen, and they are pushing it pretty hard. It's been under development since 2015, and when these guys started, they knew absolutely nothing about rocket science or orbital mechanics or anything, and they learned it all. And it's quite amazing. It's a physics simulator that fairly accurately models how rocket flight and air flight works. It is a two-body system. You've got spheres of influence. It does not have n or 3 bodies, so it does not simulate Lagrangian points or that kind of thing. But in this simulation, I hesitate to call it a game because it is a simulation. You can build rockets Lego style, click them together, and anything from small little probes to Apollo style things, which I'll be showing you. And excuse me. I made a presentation. Okay, let's lower that a bit, shall we? Should I just lower the music down myself? I was testing it here, music show. There we go. We definitely want the sound up though, because sound is a big part of this simulation. Okay, so it has, just go through the start menu here. This brand new version has got a whole bunch of missions and training and scenarios. And the training one is very, very basic on how to click like 3 parts together and fly a mission, flying the mission, getting it back, building something bigger, going suborbital, getting orbital, building, collecting science from space, getting to another planetary body, docking, which is the hardest thing I have ever done in any game ever. Now this is pretty interesting. The asteroid redirect mission, while this game was under development, NASA came to them and before the redirect mission was canceled and said, would you like to include this in your game? And they said sure, so they put an actual NASA mission in here, and so they're able to use the NASA blue meatball logo and it's in the game. So that's pretty cool. So let's resume and save last presentation. Now, so my wife and I ran this Endeavor Space Academy, and the middle school students, they just loved this. I had this running at an astronomy night that the WASP helped us out with there. I wandered in there once and I saw this 7-year-old kid. He was smiling so big I thought his face was going to break. I'm not sure he knew what he was doing, but he was having a ball. So here's the Space Center, and the vehicle assembly building looks like, big square vehicle assembly building in NASA. This is where you've got all your parts, and it's got a lot of them. It's got several different modes of play. The Sandbox mode, which is what I'm in right now, is everything. You get everything, and if you start off with this, you're going to be, what do I do with all these parts? But it's got a career mode, which you start from like you've got a probe core, and that's it, and maybe a thermometer and a barometer, and that's it. You collect science, and you'll eventually get all of these parts. But, so let's open up the spaceship I made for there, right there. So there's a spaceship I made for this. Wow. Yeah, but I think things just click together. Click, click, just like Lego. This is the fairing, or this is where the probe is under the fairing. And I already got one canceled, don't say it. I already got one on the pad here. Let's go fly this, and I'm going to be showing some basic orbital mechanics here as we fly this. Wow, that's pretty loud. I'm going to have to lower that a little bit. I don't want to blow you out of your seats. So, right here, where I'm launching from, and actually let's accelerate time to launch in the daytime. All right, good. Now I'm using a cheat here because I don't want to do this manually. I'm using a mod which does ascent guidance. There we go. 250. My path, that is correct. All right. Okay, so it goes up straight for a little while, and I reach 100 meters per second. It's going to start gravity. And that is where you start bending over horizontally. This is a fuel saving technique where you get some horizontal velocity, but you don't just want to go straight up and then do that. Huge waste of fuel. So as I'm going up here, the high point of my trajectory is called my apoapsis.
Bob, closer to Mike.
Okay, the high point is called the apoapsis. This is the high point of my orbit. I don't have a low point, it's under the surface. Currently I'm suborbital.
Now, can you turn the volume down a little bit more?
Okay,
About 40.
sorry.
Thank you.
Is that better? Yeah. Maybe a little more. There we go. Okay. So this is my apoapsis. This is the high point of my trajectory. And it's growing up. I've told it to go to 250. So I'm bending way over here. See my atmosphere starting to thin. Now, so I'm going to stage here in just a second. My lower stage is almost out of fuel.
Are you in real time?
This is not Earth. This is Kerbal in the game. It's 1/3 scale, but the same gravity. So here's I'm going to stage. I love watching those things fall away. So that stage is just going to fall into the drink. And now I'm going to blow the fairing, which is this thing. Save a few pounds. Now this is going to act as the section that gets me into orbit. I haven't reached my high point yet. I will soon. Once I reach my high point, I'm going to circularize the orbit. Now this is the way it happens in this game. Sometimes they actually do this. Many times what they'll do is that they'll get into orbit in one shot. You don't necessarily have to circularize, or if you do, it's just a little bit. And I'll show you what happens when you circularize here. I have almost reached the high point I told it to go. I'm going to stop thrusting. There we go. So now I can get into the position I need to be. So now I'm going to circularize my orbit. I'm going to look at it straight down here. Let's turn the space station and that off. Okay, so I'm going to the high point of my orbit here. I'm currently still suborbital, and this is going to, now I'm here, I'm looking this way, I'm thrusting this way, and watch what happens to my orbit. It pushes on the other side of the body you're orbiting. First time I saw this, I'm like, oh my goodness. So again, I'm facing that way, I'm facing that way, but when you thrust the way you're going, it pushes your orbit out on the other side, and so now I'm in a perfectly circular orbit. Which is what a lot of people think of when they think of orbits, but they're not always circular. So the next thing I'm going to do is I want to go to a different planet. Let's turn that off too, and I'll get to that in a minute. I'm going to go actually to the moon. And again, this is not the Earth and not the moon, this is the moon. So that's my target, and what I'm going to do now is, unfortunately, I don't have a PowerPoint about this, but I'm going to do what's called a Hohmann transfer. This is a transfer method designed by a German mathematician, and what it is I am orbiting in the same plane as my target. Right there, right? So I can do a Hohmann transfer of this. So there's a create the node, and that is a Hohmann transfer. Now it's taking me right to the center of gravity of the moon. I don't want that, so I'm going to tweak it a little bit here. And there's two different ways I can go around the moon. I can go around the moon this way, or I can go around the moon that way. And Jeff, what's going to happen if I go this way?
Hey, free return.
There you go. So I've got a pair. I'm going around the moon. The moon is orbiting in this direction. I'm going around it in the opposite direction. And plus. There's your free return trajectory. You come back, you're really close, maybe do a little bit more. There you go. That can probably just, there you go. That's your free return trajectory. I might not even have to do a maneuver adjustment here, but this will take me back in for a re-entry. Now, if I go around the other way, plus. That's going to kick me right out of orbit. That's going to be a gravity assist, and that's going to kick me right out of, I'm going to escape the planet. So I probably don't want to go that way. But it doesn't matter because I'm going to be going into orbit anyway, so let's just execute that. So now I've got a maneuver node. It's figured out where I need to start pushing to achieve that trajectory, so I execute that. What my spacecraft does is it gets into the position it needs to be to make that maneuver. So there it is, right there. And again, remember, I'm thrusting there this way, so it's going to push out that way. There you go. Now I'm in an elliptical orbit. Let's get over here and see from this point of view. So my apoapsis is stretching way out here, and this is going to be where I encounter the gravitational force of the moon, and then I will be within its sphere of influence like that. That's enough, all right. Okay, so now it's the big weight. Let's see, I want sunlight on my probe, so I'm going to do that. There we go. All right, so now I warp here because I don't want to spend days or hours waiting for this thing to get to the moon. That green line you're seeing there is the communication line back to the base. So now I'm slowly leaving the Earth, Kerbal coming up on the moon. And right about there, I'm in the sphere of influence of the moon. And what's really interesting is when you zoom way out and you go to the Jupiter equivalent in here, which is right here, the sphere of influence is way out. I actually went here when Juno was going in orbit around that, and it was the Juno went into the sphere of influence of Jupiter about a month before it went into its capture orbit, and this was about a month out when I reached that planet. So at this point, what I want to do, think of this like a swing. I'm coming around this planet like this. I'm in a parabolic trajectory. I'm gonna, if I don't thrust at all, I'm gonna whip by, and I will be on that yellow trajectory. If I don't do anything, well, that's not what I want to do. I want to go in orbit. So I want to go in orbit at the periapsis here, because that's where you're going the fastest. Think of a swing. You're coming around, you're going really fast right there, and then you start slowing down. Same principle. And that's called, the reason you want to do that there is called the old birth effect. So you create a maneuver node here, and you pull backwards until you're in orbit. Now that's elliptical, and you keep pulling, it will get you into a circular orbit. Just like that. And we're going to execute that. So now my ship is getting into the maneuver position it needs to be when it's at that node. From my standpoint, I'm not moving right now. I'm whipping around the planet. I love how it changes that viewpoint on you there. So now what I'm doing, I'm traveling in this direction, I'm thrusting in that direction, and it's going to take my orbit, and now I'm in orbit with the moon. And there we go, and that's pretty much how it's done. So now I want to land. And what we gotta do is I want to land in a nice flat area there. And where am I there? So just warp to here first again. I don't want to wait 45 minutes for it to come around the other side of the moon.
You have enough fuel to do all this?
Hmm?
Do you have enough fuel to do all this?
Yeah. I've got, yeah, this day, that will deorbit me, that little bit right I've got will deorbit me, and then I've got a thruster and a tank up there, so it'll land. Okay, so I'm there, and I'm going to put a maneuver node right about there. And again, I need to reduce my velocity, and now I'm suborbital. And let's point it right about like that. Execute. I can do all this myself, but it would take me about 5 times as long, because I'm real paranoid when I go to land on the moon or anywhere. So now I'm thrusting in the direction I'm going again, and this is going to take my orbit and just got enough fuel there. All right. Cool. All right, so now I'm on a very suborbital trajectory, and my deorbit stage can go bye-bye. So now, again, for the sake of time, I'm going to use the landing guidance, which is going to land for me. But before I do that, I'm going to save, just in case something happens. Because landing never fails. So, land somewhere, that's good. You just go ahead and you land somewhere. Now this is doing what's called a suicide burn. It will thrust as hard as it possibly can, as close as it possibly can. There's my fuel stage. Whoa, why are you going that way? Slow down, dude. You're supposed to land straight. What are you doing?
Aren't we going to fire a thruster?
All right, I might be doing this manually. What is going on? All right, you can
You
just
have
stop.
20 seconds of fuel left.
How much do I have left?
Mark's going to get to do it.
Well, you know
That's
what?
what he has
That's
to
not
do.
really a concern because, well, it wouldn't be a simulator if I couldn't cheat. Infinite fuel, infinite no, I'm not going
I
to.
suggest we all leave.
Infinite propellant, infinite oil.
All right, are you falling? Are you? No, you're still going up.
Speed it up.
All right. know.
Oh, we don't want to do that.
And down. Land nicely.
What would have happened if you'd have let it stay on that side
It
trajectory?
would have probably fallen over.
You're on autopilot now?
And I don't know why it was going sideways like that. Like I said, that's why I saved it. Sometimes doesn't always work. Now I'm using a lot of different mods in here. This thing, which is like the Curiosity Cam, that's one different mod. The dust experiment, that's in a different mode. Right? It'll land nice this time. There we go. It's doing that crazy sideways thing again. That's why it's doing that. All right, I'm still for it. Just click. Whoop. There we go. Whoop, whoop. So, there we go. That's a little more stable. Stay there. All right. So now let's. You collect all of your science, right? This thing's pretty funny. You fire your laser. All right, collect all that. So you collect all the information, and then let's see. I want to shut this engine down. And let's see, T, Z, and hopefully this is going to work right. This is how the sample return works. Leave that base station down there. All right, right there. So anyway, this can get back to the planet and re-enter, but I don't want to show you that. I want to show you something else. Let's go back to the tracking station and let that thing crash. Because that's what's going to happen. So I made a space station. Actually, let's show you the space station first. I made a space station for this thing, for this presentation. There it is. Kind of an over-the-top space station, actually. Added some stuff to it. This is a Mars constellation-like ship with an Orion-like ship on it. It's got a Soyuz dock to it, and something that kind of looks like a Gemini dock to it, and Taurus, because I could. So, I'm going to show you, let's see,
Has a Ferris wheel.
well, there's actually people in there. I can show you the picture, and you're looking out the window, you probably throw up because you see the station go by like that.
It's supposed to be a gravity simulator.
Yeah, and I love this too. See, this has got a counterweight. But anyway, what I wanted to show you is this game lets you do docking and re-entry and stuff like that. I'm just going to undock from here.
Gemini.
Couple, there it is.
Takes me back.
Very sophisticated program.
So just think of this in reverse, and you can dock. I did dock this thing, but I didn't build this all launching. I cheated. I built that whole thing and just put it up into orbit because it's a simulator and you can cheat.
How many G's are we producing in this?
Right now, I've got no G's at all right now. Let's see. What I want to do now is, again, I want to land at pad, set that to 60, and land at target. And abort because I got to turn my engines on. Yeah, now I want to land somewhere. What I told you to do. I am doing the retro VR version. And there I just went so hard. See, it changes perspective on it. I love that. We're just gonna let that go there. All right, so
Bobby, you found any extraterrestrial life?
Just these guys. All right, so now I don't need that deorbit section. And because, again, I don't want to wait 5 minutes, I'm going to time accelerate. So it slows down there when I've entered the atmosphere. And I'm going to speed up again.
When something major happens, does the simulator slow down automatically?
Define major. Like your ship crashing and blowing up, which actually
shield falls off.
all the time, or maybe you don't have enough of blader on it, like I might not. You can see this from the cockpit, and supposedly you can fly an entire flight IVA like in a cockpit. I can't do that. That would be my re-entry session blowing up. There it is, blowing up above me. Unfortunately, I don't have a mod in here right now with this version. It doesn't work with this version, but when you're here, things are just shaking, and it's very, very scary. I love the re-entry part of this.
Does it give the temperature of your heat shield?
Let's see. No, I could put a thermometer on it. It's not telling me that. Sorry. Okay, so I have that's the drogue chute. I've just come out of the plasma phase of the reentry, and as soon as that happens, the drogue chute pops out. That's slow. The drogue chute pops out at very high speeds, with it's a very high strength, and then the main chute pops out. Am I going to hit the land or the water there?
So does this have the shuttle option as well?
It has a shuttle. I can't fly it very well. I've never successfully landed. They've got a scenario where the shuttle is coming right down on the landing field, and I just can't do it. I just can't do it. The other piece just blew up there. Let's see, cut that drogue chute, can I? Bye. Unfortunately, it's not splashing down, because that's pretty cool, but it's doing a more Russian-type landing right now. Recover, so that is pretty much, well, recover a vessel, that is how you end a mission. You recover the vessel, and they're assuming that, planes or helicopters, whatever comes in and gets it. Now, some of the other things I made for this scenario.
Where's the den last 5 minutes?
Okay, I'll show you the lost polar orbiter. This thing is a polar orbiter that's very similar to the Lunar Reconnaissance Orbiter or the Mars Reconnaissance Orbiter. And what it's got is, let's hit F10, and I'm going to deploy all this stuff. Like origami. So what I've got here is, I am in a polar orbit. I am orbiting the planet. Now I'm scanning the planet. You see how it's scanning like that? And this is showing you what I've scanned. So let's speed it up. So I'm orbiting the planet now, and scanning it in swaths here, as you can see. And then this is how the polar orbiters actually work.
You said this is a lunar.
Well, it's similar to the Lunar Reconnaissance Orbiter or the Mars Reconnaissance Orbiter. Both of those are in polar orbits.
Right.
And they scan the planet as it rotates underneath, right? So that's exactly what this is doing. So that's just demonstrating that. And let's see, other cool thing.
Can you look at the map?
Yes, you can.
Oh, I guess the map is at the left there?
Well, you can make it big, you can make it bigger. And you can also do resource types. And there's just a ton of different options.
Do they have the Mercator projection?
What?
The Mercator projection.
I don't know.
Let's not go there tonight.
So, one of the other things that this thing has, which is pretty interesting, is it's got asteroids. And like NASA has this asteroid redirect mission.
Is that to actually redirect asteroids to closer to Earth?
Yep. And yes, you can mine them, just like I'm doing to this guy. Hey, what are you doing here? Up there. That's a spaceship, and it is actively, are you mining? Oh, there, start the asteroid. There, now it's harvesting. So, camera here. So yeah, I am actually harvesting that asteroid. And it's got a clamp to clamp onto it. This is an ore container, and then we'll get back to my space station and I can transfer the ore. So yeah, there are missions to go capture asteroids, redirect them, collect X amount of ore. So these are future space missions.
So you can push them away from smashing in the Earth?
Yep, there are missions to do that, and you've got to use the whole orbital rendezvous and docking stuff with them, and it's really, really cool.
You got it full time, Bob.
Okay, that's pretty much it. Any questions? So I'm really pleased to see how far computer games have gone and how much they are adding to the field of astronomy and space science. I certainly like this game. I've boxed 2,900 hours on it so far.
Are there any questions? We got time for like one or two? You pick your question.
So, have you tried launching inside the VAB yet?
Inside the VAB?
Yeah, have you done that yet?
You can't do that, no, you gotta launch it in a pad.
You haven't even tried it?
No, you can't, there's no way to launch it, it's not an active vessel because it's only Lego in the vehicle assembly building. And well, but the first one, NASA Eyes, get it? It's free. Think NASA Eyes, you'll find it. It's really a cool app.
How much is this one?
Free. This is $40. It goes on sale for $25. It is available through teachergaming.com at a teacher discount for $17.
If you're a teacher.
Well, actually no, I signed up as a other educator and got that freeloaded.
All right, let's thank Bob one last time. So, for those of you that can stay up all night,